everyone, and welcome to our functions lessons. And in this lesson we will look at the introduction to the exponential function. Now before we look at this equation here, I want you to note that it doesn't matter which letters we actually use. Okay, so you will see here that I say that the exponential function is of the form y equals a times b to the power of x plus q. It's called an exponential function because there is the x and x is an exponent. Okay, so that's how we know that we're busy with an exponential function, because the x is actually an exponent. Now what I'm trying to say is, well, we can say that it's y equals a times b to the power of x plus q, or sometimes some books will also say that it's y equals b times a to the power of x plus q. Now it doesn't matter what letters we use, but you have to know the following. As long as you know that there's an exponential function and it has a coefficient to the power of 1. So look, here's the coefficient. So it will be a number value to the power of 1. But here the coefficient is a b. So it will be b to the power of 1. Okay, and that's usually a number value. Okay, so it doesn't matter if they swap the a and b around. You just have to know there's one number coefficient to the power of 1. And then there is a base to the power of x. Here the base is the b to the power of x. Here it is a to the power of x. So I just wanted to show you these two, but we will work with this first equation to show you the meaning of these values. Okay. So don't get confused if they give you this one and they ask you to solve for b and for q. It means exactly the same as if we have this one and we need to solve for a and for q. So basically we are solving for a number coefficient, and sometimes we solve for the base to the power of x, and that is my asymptote. And we will look at these values in due time. So we are going to work with this function here. Okay, so forget about this one for now. Q is the asymptote. So just like with our hyperbolas, we know that the q is the asymptote, so it is a line which our exponential function cannot cross. Okay, that a, which is the number coefficient, please know that I'm talking about the number coefficient. In that function it's actually the b. The a tells us if the exponential function is above or below the asymptote. Very important to remember. If a is greater than 0, so if that is a positive number coefficient, okay, that means the function is above the asymptote. If a is less than 0, it means that the function is below the asymptote. And a can never be equal to 0, because then all of that will be 0. Okay. So what does the a tell us in the equation? It tells us that the function is either above the asymptote if a is a positive number, a value bigger than 0. And if a is less than 0, well, we have a negative a, and then the function is below the asymptote. Let's look at the value of b. B tells us the following. Now, b is the value to the power of x. In other words, the base to the power of x. In that equation, we are referring to the a, okay? So this tells us the shape of the exponential function. Very important. Now, if we read from left to right, as we do in English, we read from left to right. So if b is greater than 1, the graph moves away from the asymptote as we look from left to right. So from left to right, see, it moves away from the asymptote from left to right. If b is greater than 0 but less than 1, in other words, b is a fraction, like here, the graph moves towards the asymptote as we go from left to right. So it will go like this, towards the asymptote, okay? Similarly, if the a was smaller than 0 and then we look at b and b is greater than 1, the graph moves away from the asymptote. So we will be below the asymptote, it will move away from it as we go from left to right. If b was a fraction like here, we will move towards the asymptote from left to right. Okay, and we will look at that in due time as we work through these examples. Now, here we have the function y equals 2 to the power of x. Now let's just quickly see what we have here. We have y equals and then we know that it's of the form a times b to the power of x plus q, right? Okay, so now let's look here. What is the a in this example? It's a 1. In front of this 2 there is a 1, so that means 1 times 2 to the power of x is still 2 to the power of x, so my a is a 1, okay? Then what is b to the power of x? It's 2 to the power of x, and then plus q. What is plus q? It's plus 0. So basically my asymptote is at 0. That is this purple line. See, similar as with the hyperbola. We draw this horizontal asymptote, and what will be that equation? It will be y equals 0. Okay, so any horizontal linear line that passes through the y-axis is called y equals 0. Now, how about this? We know that a is a 1, right? So if a is greater than 0, then the function is above the asymptote. So that a is a 1, it's greater than 0. That is why this function is above the asymptote. Can you see the red line? It's above the purple one, right? Okay, how about b? If b is greater than 1. Okay, well, b is greater than 1. Can you see? It's a 2. So what do we know now? It will move away from the asymptote as we read from left to right. So it starts close to the asymptote and then it moves away from the asymptote from left to right. Okay, easy enough, right? Okay, so how about the next one, the purple one? Now let's see what happens here. Here we still have an exponential function. How do I know? Because there's the x, which is the exponent. Okay, brilliant. So now, all that happens is, if I close this plus 2 with my arrow, can you see that we still have y equals 2 to the power of x, which is the same as the red one here. So let me just quickly put that one in, and you can see. Okay, so there's my purple one on the red one, and that's what we're talking about. Okay, great. It fits there. There we go. So now, but what happens now? The asymptote moves up 2 places. So this graph moves up 2 places. So look, it moves up 2 places, and my asymptote is now at positive 2. And still, look, so a is still a 1, and that means if a is greater than 0, it's positive. The line will be, or our function will be above the asymptote. Can you see the purple one is above my asymptote? Then 2 is greater than 1 as well. That means b is greater than 1, because remember, the b is the base that has the power of x, and that is the base that has the power of x. That b is greater than 1. That means the graph moves away from the asymptote. So from left to right, it moves away from the asymptote. And then plus 2, that is my q, and my q is my asymptote, and there it goes through to right there. Okay, brilliant. Now let's look at the next one, and I'll remove this purple one there, and then let's have a look at this blue one. Now we still have an exponential function. How do I know? Because x is an exponent. So exponential functions is of the form y equals a times b to the power of x. What is my a here? It's still a 1, okay? Because 1 times half to the power of x is still half to the power of x. So there we have a, which is a 1, and when a is greater than 0, when a is positive, then the function is above the asymptote. Okay, so we know that this function will be above the asymptote. But now, look at b. b is a half, because that is the base that has the power of x. And if b is greater than 0 but less than 1, in other words, it's a fraction, then the graph moves towards the asymptote. Now let's see what this one looks like. So if I go and draw it in, it will look exactly like that. Okay, so basically we know that it will be above the asymptote. Why? Because there we still have a that is bigger than 0. It's a positive a. Now, because b is a number that is greater than 0 but less than 1, it is a half, we know that it moves towards the asymptote. So from left to right, can you see it moves towards the asymptote? Easy enough, isn't it? Now let me quickly remove these two graphs. There we go. And now I'll also remove this one. and then we just have an open Cartesian plane because I really want to go and change these equations. So let's go with the red one first. So I'm going to change that to y equals, and then I'll say minus 2 to the power of x. Now what if we have an exponential function that is y equals minus 2 to the power of x? Again, this is an exponential function because x there is an exponent. But now, please remember that this is the base that has the power of x. That minus is actually a minus 1 times the 2 to the power of x. So a is less than 0. It's a minus 1. And when a is less than 0, then the function is below the asymptote. So let's quickly go and have a look what it looks like. So if I take this and I draw in my asymptote there, and remember it's plus 0, so my asymptote is on the 0, and then look quickly what's going to happen. This entire function is going to be below the asymptote. Now don't worry about the shape yet because we haven't looked at the b. Now this is 2 to the power of x, that is b, and if b is greater than 1, the graph moves away from the asymptote from left to right. So look very closely. From left to right, it starts close to the asymptote and moves away from the asymptote. Easy enough, right? And that will be my y-intercept. And don't worry, we will calculate that in the next lesson. I will show you how to draw it. And in the lesson after that, we will learn how to determine the equation. But for now, I want you to know just what it looks like and why it is below the asymptote and why is it in this shape. Okay, so let's go and look at the next one, this purple one. And I'm going to change that purple equation and I'll write it in purple as well. Let's go and make it y equals, and then we say minus 2 to the power of x plus 2. Now again, all exponential functions is in the form of a times b to the power of x plus q. There's always a, okay? So that is minus 1 that I can put in there times the 2 to the power of x. So there's my a, which is minus 1. And minus 1 means that a is less than 0. So the function is below the asymptote, right? And there's my 2 to the power of x. That's my b. And if b is greater than 1, we know that it moves away from the asymptote. If b is greater than 1, the graph moves away from the asymptote. So let's see what this purple one will look like if we put it in. And there we go. Similar as before, but look what happens now. Plus 2. So that means my asymptote is at plus 2 on my y-axis. So this entire one moves up. There we go. And look where it goes now. Okay, so the asymptote moved up. So my function is still below my asymptote, but it goes from almost touching the asymptote away from it as we read from left to right. Why? Because b is greater than 1. And it's below the asymptote because a is less than 0. It's a negative number. Okay, brilliant. So let's remove this one as well. We go put that away. And then we also put this one away. And then we look at the last one quickly. So I'm focusing on this blue equation here. And I will write that in blue as well. So let's say it is y equals minus, and then we have a half to the power of x. Okay, great. So again, what is my a? It's minus 1. So when a is less than 0, when it is negative, then the function is below the asymptote. So this one will be below the asymptote. Where is my asymptote? It's plus 0, so it's on my x-axis. And then look at b. b is a half. And when b is greater than 0 but less than 1, in other words, b is a fraction, the graph moves towards the asymptote. So let's see what that looks like. So if I draw this in, I know my asymptote is on the x-axis. And then b is a half, a fraction. So it moves towards my asymptote as we read from left to right. Okay, and we will learn how to calculate the y-intercept later on. So can you see how easy this is actually? So you just have to remember exponential functions is of the form a times b to the power of x plus q. Q tells us where the asymptote is. A tells us if the function is above or below the asymptote. and the base that is to the power of x, that b, tells us what is the shape of the graph. Does it move towards the asymptote or away from the asymptote? So work through this lesson. There's a couple of interesting and important things to remember, and then we will go and look at how to draw it in the next lesson. See you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.